Hey everyone, today we are going to look at a method for solving quadratic functions that is just a little different. It's probably something that you have not seen before. And so for that reason it can seem a little intimidating at first, but actually I really like this method. Once you kind of get used to it, I think that it has fewer steps than like the quadratic formula, for example. And so I really like it. So try to keep an open mind and be patient. Here we go. We're going to look at a method called completing the square, and we are going to essentially manipulate our quadratic function so that the left side, the side with the x squared, has a perfect square over here. So this b over 2 quantity squared is something that we'll talk about. Don't let this formula scare you. It's going to make sense by the end of this. So first, let's look at a problem where the last term, or the constant, is already a perfect square, because if I take the square root of 49, I would get 7. So I can go ahead and factor this in. Well, if you want to see it with two sets of parentheses, it would look like this. But we know, hopefully, that if it's a perfect square, I can go x and 7, and then whatever this sign is, quantity squared. It's the same thing, equal to 81. So if you want to do this step, it's okay, but I'm hoping that we'll be able to just kind of eliminate that step altogether and jump straight from here down to here. All right, so now at this point, this is a special case. We looked at problems where we had x squared equals 81, and how did we solve for x there? We took the square root of both sides. And so the same thing's going to happen here. I'm going to take the square root of the left side and the square root of the right side. And I can do that because all of this, the x and the minus 7, is all being squared. It's not x squared minus 7. It's x squared minus x minus 7, quantity squared. So now, when I take the square root, I'm going to get two answers. What two answers do I get when I take the square root of 81? I get 9. But I also get negative 9. So I'm going to write this twice. I'm going to write x minus 7, because a square root and a square cancel each other out. So on the left-hand side, I'm going to have x minus 7. I'm going to write that a couple of times. But I'm also going to have equals 9 and equals negative 9. So on this side, this becomes pretty easy to solve. I just go plus 7, and I get x equals 16. Over here, I would do plus 7, and x equals negative 2. And there you have it. Those are my two answers for this problem. Now, this worked out pretty well because the left-hand side of our original problem was already in the perfect square trinomial form. It was already written that way, but not every problem is going to be like that. So we are going to manipulate these problems so that they look the right way. So let's practice what we need to do to make this look right. The key was this, b over 2 squared. All right, so I'm going to take my b term, and I'm going to divide by 2, and I'm going to square it. So 6 divided by 2 is 3, and 3 squared is 9. That means that I would put this here. If I wanted to take it a step further, I could factor that to look like this. All right, so for this one, I'm going to end up with a fraction, but that's okay. I'm going to have 7 over 2 quantity squared. When I when I square that, I'm going to end up with 49 over 4. And I'm just going to leave it as a fraction. I know that's y'all's favorite thing ever, is fractions, but we're going to get plus 49 over 4. All right, so we are going to solve by completing the square. Now, don't be fooled. This looks like, oh, it's already a perfect square, but if I tried factoring this, I would be saying, all right, what multiplies to 4 and subtracts to 4? Well, nothing, because 4 times 1 is 4, but 4 minus 1 is 3, and 2 minus 2 is 0. So neither of those actually work. So when this is not already a perfect square, my very first step is to move the constant to the other side. and I'm going to get x squared plus 4x, and then I'm going to put plus blank equals 4. And this is going to look like those problems that we just did where we completed the square. And I'm going to say, what do I need to fill in to this spot here to make this be a perfect square trinomial? Take my b term, divide by 2, and square it. So this is going to give me 2 squared, which is 4. And it might seem silly, but again, that minus sign made all the difference. But here's the thing, I can't just add 4 into a problem randomly. I can just be like, I want that to add 4. I have to keep things balanced whenever I'm working with equations. So if I add 4 to the left, I also have to add 4 to the right. And my new equation is x squared plus 4x plus 4 equals 8. Well, this I can rewrite, again, hoping that we can start skipping that step. I know that it's a perfect square because I made it that way. And so that's going to be a 2 there. This sign goes in the middle. Quantity squared equals 8. Now, I am going to take the square root of each side. And this is why yesterday we practiced with radicals. If I wanted to simplify radical 8, because I cannot take the square root of 8, I would get a decimal. I would get 4 times 2. This would give me 2 and 2. So I would circle a pair of 2's and have a 2 left over. So the square root, and the square cancel out. So I just get x plus 2 equals 2 radical 2. And I get x plus 2 equals negative 2 radical 2. Always get the 2 answers. To solve this, I'm going to subtract 2. Subtract 2. I know that's a lot of 2's. And since this one here has a radical, I can't just do 2 minus 2 is 0. I have to, I'm going to write this as x equals negative 2 plus 2 radical 2, and x equals negative 2 minus 2 radical 2. So if you write your answer like that, that's fine. If you have a number that is not a perfect square, you could also write your answer like this, where you had a simplified radical. You have all the options. So you can either do this, or you can do this. Either one of those would work. All right, again, this looks like a square number, but that minus sign means it's not going to be a perfect square trinomial. So I'm going to start by adding 1 to both sides. Plus blank. All right, so I have x squared. Oh, let's fill that in actually, sorry. So I would take my b term and do b divided by 2, quantity squared. Well, that would give me 1 squared, which would just be 1. All right, so I'm going to have, when I factor that, x, this sign right here, so minus 1 quantity squared equals, but then remember, I got to add 1 to both sides, so equals 2. Let's do that. Take the square root of both sides. This one, on the last one I showed what happens if I write it twice. This one, because I know I can't simplify the square root of 2, I'm just going to leave it as radical 2, but with a plus or minus in front of it. Just because I want you to see 2 different ways to work these out. So I'm going to add 1 to both sides, and I get x equals 1 plus or minus radical 2. So if you're comfortable with the simplified radical and just leaving it plus or minus radical 2, that's fine. If you need to write it out 2 different times so that you remember what's happening, like this, you can do that too and get 2 separate answers. Either way, it's going to end up being the same thing. All right, so for this one, I already have my blank on the left side. If I just want to rewrite it with a little more space, there we go. I can do that. Some people, what they'll do is if they have a blank on the left side to fill in, they'll also put a blank on the right side just to remind themselves that they have to add that to the other side. So in this case, what's going to go on our blank to complete the square? I'm going to take b over 2, quantity squared. which would give me 3 squared, which would give me 9. So 9 goes here, and 9 goes here. X squared, oh, actually I'm just going to go ahead and factor it. X plus 3 equals negative 34 plus 9, which would be negative 20. I'm having a moment. Negative 25. All right. So we are going to take the square root of each side. And what we were doing last lesson is going to come in handy again. Because we have the square root of a negative. What happens when we get the square root of a negative? We have an imaginary number involved there, so we're going to get an I. So I'm going to write x plus 3 equals plus or minus 5i. Now, this is another case where, because it's plus or minus 5i, you can just leave it like that, or you can do like we did here and write it out twice. You can also write it as x plus 3 equals 5i, x plus 3 equals negative 5i. The only time that you have to write it twice, like I was just showing you, would be in a case like this, where if we take the square root of the number, we get a positive whole number, like 9. Because if I just did x minus 7 equals plus or minus 9, this would not give me an accurate picture. So that is not correct. All right. So I'm going to subtract 3, and I get x equals negative 3 plus or minus 5i. And that would be my final answer. Again, you could solve this over here and write it twice, but you don't need to.